Voyager 1, the farthest man-made spacecraft from Earth, has just made contact with an unidentified and highly advanced object in deep space. Join us as we embark on this remarkable adventure of discovery and try to solve the riddles of this interplanetary encounter. Voyager 1 is presently 14.3 billion miles distant from Earth as of May 2023. In comparison, Voyager 2, its twin, is currently 11.7 billion miles from Earth. This indicates that Voyager 1 is 2.6 billion miles further away from Earth than Voyager 2. There are several explanations for the disparity in distance between the two spacecraft and Earth. One of the primary causes is their divergent paths. While both spacecraft were launched in 1977 and traveled in similar directions to our solar system's outer planets, their courses diverged after Voyager 2 finished its original mission. Voyager 2 moved on to study Uranus and Neptune, while Voyager 1 headed for the solar system's outskirts. Voyager 1 just made contact with a highly advanced object in space. Voyager 1 and 2 discovered active volcanoes on Jupiter's moon. They also revealed Saturn's complicated ring systems and the hexagonal cloud structure at Saturn's North Pole. The Voyager 2 spacecraft was the first to visit Uranus and Neptune, revealing their complex atmospheres and moons. In 1989, the Voyager 2 spacecraft visited Neptune for the first time, collecting stunning photos and gaining revolutionary data about the faraway planet and its moons. Voyager 2 was outfitted with a set of scientific instruments to investigate Neptune and its surroundings. 6 new moons were discovered around Neptune by Voyager 2, raising the planet's total to 13. It also produced the first detailed photographs of Neptune's rings, indicating that they are made up of small ice and dust particles. Voyager 2 also flew close to Neptune's largest moon, Triton, displaying a landscape unlike any other in our solar system. Geysers on Triton, identified by Voyager 2, blast nitrogen gas and dust hundreds of feet into the air. It also discovered signs of a youthful surface, with few impact craters indicating that Triton is geologically active. The expedition of Voyager 2 to Neptune was a triumph of human ingenuity and discovery. The spacecraft's data and photos have changed our understanding of the outer planets and their moons. On January 24, 1986, Voyager 2 arrived at Uranus, passing within 50,000 miles of the planet's cloud tops. Here are some of the most important discoveries from the Voyager 2 mission to Uranus. The discovery of 10 new moons around Uranus by Voyager 2 brings the planet's total to 27. It also revealed an unusual magnetic field that was slanted at an angle of 60 degrees from the planet's axis of spin. Voyager 2 also flew close to many of Uranus's moons, including Miranda, whose surface appears to have been broken and then reconstructed. The surfaces of Uranus's moons range from extensively cratered to reasonably smooth, as discovered by Voyager 2. The existence of ice and chemical compounds on some of the moons was also found by the probe, boosting the prospect that they could support life. The fascinating news is, NASA's Voyager 1 spacecraft was the first man-made object to enter interstellar space. Its journey has provided us with a glimpse into this unknown region and has taught us a great deal about the universe. Voyager 1 passed the limit of our solar system and entered interstellar space in 2012. It keeps sending back information about the cosmic rays and magnetic fields it encounters. Interstellar space, according to Voyager 1, is not a total vacuum, but rather an area filled with dust, gas, and cosmic rays. It has also identified a mystery hum, or low-level vibration, that scientists are still trying to figure out. Another mind-blowing discovery by Voyager 1 is the details about the heliosphere. The heliosphere is the region of space around the Sun that is influenced by the Sun's magnetic field and solar wind. The heliosphere was discovered to be far larger than previously imagined and asymmetrical, being pushed and molded by the interstellar wind. The density of the solar wind was also discovered to be diminishing when Voyager 1 reached the heliopause, the barrier where the solar wind meets the interstellar medium. This was a clear indication that Voyager 1 was on its way out of the solar system. Voyager 1 finally crossed the heliopause on August 25, 2012, officially entering interstellar space. Thus, Voyager 1 became the first human-made object to leave the solar system and enter the wide expanse of interstellar space, which was a historic achievement for the project and for humanity. In 2018, Voyager 2 became the second human-made object to enter interstellar space. The journey of Voyager 2 into interstellar space was not simple. The spacecraft's instruments observed a dramatic decrease in the quantity of charged particles emitted by the Sun in 2017, indicating that Voyager 2 was reaching the heliosphere's edge. Voyager 2 finally crossed the heliopause on November 5, 2018, Officially entering interstellar space, the trip of Voyager 2 across interstellar space has been as amazing as its trek through the outer solar system. It discovered a higher density of cosmic rays, revealing new information about the interstellar medium. It has also identified a magnetic field that is not aligned with the Sun's magnetic field, indicating that Voyager 2 has reached a new region of space. Earlier this year, Attitude Articulation and Control System AACS of Voyager 1 began transmitting confusing data to mission controllers concerning its actions and health. The AACS is a critical component of Voyager 1. The gear is responsible for keeping the spacecraft's antenna aimed at Earth. Without it, all of that important scientific data would be lost in space. The problem was that the AACS's data was jumbled, leaving the team in the dark about the spacecraft's health and activity. It turned out to be a networking problem, comparable to what IT workers may experience on Earth. Essentially, the AACS was transmitting telemetry data, but it was being sent to the incorrect computer. Worse, it was an old computer that had failed many years before. This really distorted the data, resulting in the bizarrely garbled communications received by the ground team. It took the team some time to figure out what was wrong, and it was unclear why AACS suddenly began sending data to the wrong machine. Most likely, it received an incorrect command from another machine. That means that they will have to fix a problem somewhere else. However, the problems have not yet posed a hazard to the spaceship. Fortunately, a data glitch has been rectified by NASA engineers. Voyager 1 travels faster than Voyager 2. This is because Voyager 1 had a gravitational aid from Jupiter, which provided it with a speed boost that Voyager 2 did not receive. Voyager 1 is currently traveling at a speed of around 38,000 miles per hour, whereas Voyager 2 is traveling at a speed of approximately 34,000 miles per hour. Did you know? The Voyager 1 and 2 spacecraft are considered to be among the most successful and famous space missions in history. NASA, the Jet Propulsion Laboratory, and several international partners collaborated on the mission. The two spacecraft were similar and carried a suite of scientific instruments designed to examine the planets and their ecosystems. Voyager 2 was the first to be launched on August 20, 1977, followed by Voyager 1 on September 5th. They were launched on Titan III rockets and used gravitational assistance from the planets to accelerate and modify their direction. The primary purpose of Voyager 1 was to investigate Jupiter and Saturn, which it accomplished admirably. However, after accomplishing its primary goal, Voyager 1 continued on its journey, pushing further and further into space. The Voyager spacecraft flew by Jupiter, Saturn, Uranus, and Neptune, delivering breathtaking photographs and data that transformed our understanding of these distant worlds. Voyager 2 also flew by Uranus's moon Miranda, revealing a complex and diverse surface. The Voyagers continued to fly outward after completing their planetary missions. Voyager 1 was the first human-made object to enter interstellar space in 2012, and Voyager 2 followed in 2018. The Voyager 1 and 2 spacecrafts have gone down in history as two of the greatest space missions ever attempted. Their legacy will continue to inspire future generations as we strive to push the limits of research and comprehension. Since it left our solar system, Voyager 1 has made incredible discoveries. It has identified the powerful magnetic field near the solar system's outskirts, which shields us from hazardous cosmic rays. It has also identified a mystery tsunami wave triggered by a big solar outburst. In the form of the Golden Record, Voyager 1 also contains a message from humanity. This record contains sounds and visuals from Earth, which are meant to represent our planet and species to any prospective extraterrestrial life that may come into contact with the spacecraft. Voyager 1 has changed our perception of the universe and our place in it. It has shown the amazing intricacy and beauty of our solar system, as well as the expanse of space beyond. And who knows what else it will discover as it continues its trip across intergalactic space. Subscribe to our channel for more information on this remarkable finding and to join us on our voyage into the unknown. Our quest for knowledge and discovery knows no limitations, and we will continue to explore the universe for answers. By the way, did you know Voyager 1 just sent out a terrifying message back to Earth? Curious to know more? Check out this video. Bye for now.